Hello there, it's Jay here from Jay's Vintage Junk, and today I thought we'd have another look at the project Mildred's Ashtray, see if we can get this BBC up and running again. So what I've done is I've dug out this little, well, it's basically this little toy oscilloscope. I do have proper big oscilloscopes, but because I'm working down in my office here, this is actually a lot more useful because of its size. I picked this up probably about 10 years ago. It's a cheap Chinese MP3 player that some bods in China hacked into a very rudimentary oscilloscope. I do say it's pretty basic. It only samples, I think it only goes up to a few megahertz. I think my scopes, one's 10 megahertz, the other one's 15 megahertz. This is probably 4 or 5 megahertz, something like that. But for what we need to do with this computer, it will do exactly what we want, and I can place it down here on the computer like that and zoom in, and you can actually see what we're looking at. Basically, this is my good working beep, which, as I explained in the previous video, I've basically got it chopped down to just the core of the computer, just so the core will work. So we've got the obviously the disk controllers been removed. We've just got the system ROM and the basic ROM, and to be fair, we don't even really need the basic ROM in there. The system ROM would just do. We've got the 6522s removed. Obviously, because we've got that 6522 out, not having the keyboard connected doesn't actually stop it booting. Obviously you can't do anything, but it will still boot up to a basic prompt with the keyboard removed, providing you've got that 6522 removed as well. We've got the serial ULA, everything to do with the serial up there is removed. So basically all we've got is we've got the video output IC, we've got the teletext IC, we've got the CPU, we've got the video ULA, and we've got the system ROMs, well, the system ROM and the basic ROM, and basically then all the rest, we've got the RAM in there, we've got all the other glue logic still in there, but the main core of the computer is just this piece, this bit here, really. In fact, I'm actually pretty certain I could disconnect the power from that part of the board, and this, I think, would actually still boot. I might play with that at a later date. But the reason I've done this is just to basically isolate everything, so we've just got the absolute base core of the computer there. One interesting thing that I have found out while tinkering and fiddling about is you can't actually test anything on the computer really without having the video ULA in there. I don't know what I've got the circuit diagram. I managed to get it off the web and print it out and stick it all together because I don't really like working off a computer screen. So I've got the entire BBC circuit diagram here. I haven't quite figured it out yet, but without the video ULA in circuit, the clock won't run, and the clock's generated, where are we now? The clock is a 16 megahertz crystal up here, which gets divided down by I think we've got a LS7404 or something. I think it's an 04, which is you the clock generation. Without the ULA in, it's completely dead. The clock won't. The crystal isn't even oscillating. There's nothing there at all. As soon as you put the video ULA in, the clock springs to life. It produces various different clocks because various different parts of the computer need various different clock signals. Basically you've got a 16 megahertz signal which is split into an 8 megahertz signal. I think there's a 6 megahertz signal created as well for, I don't know if that's not something to do with the teletext IC. There's a 4 megahertz, there's a 2 megahertz and a 1 megahertz, all basically divided down. But like I said, without the video ULA in there, you don't get anything. Like I said, even the crystal doesn't seem to oscillate, so that's quite interesting. It's also a bit of a pain because it means, because I've only got the one ULA at the moment, and I've found one on eBay for sale, and I think the guy wants like 30 quid for it plus postage, which I just don't have that to throw at one of these at the moment. There's a possibility I've probably got one or two kicking about in my spares. If I go on a real digging frenzy, I might be able to dig a couple out. That's my hope anyway. But unfortunately, what it means for the moment is if I want to do any tests, basically any comparisons, say I want to see what a signal looks like on this, I have to put the video ULA in here, and then when I want to work on Mildred's Ashtray, I have to take the video ULA out of here and put it in Mildred's Ashtray, or otherwise, like I said, nothing on the computer will do anything. So yeah, that's a bit of an issue, because it's a bit dodgy. Keep swapping that chip backwards and forwards, and we're either going to break a pin on that, which, I mean, it's not the end of the world. Most times I can solder a pin back, or I'm certainly going to end up having to replace these sockets, because I'll have worn them out with keep swapping the chip backwards and forwards. Anyway, less of me rambling, more of me showing what I'm going to do. What I'm basically going to do is just show you the clock signal on this working beam, and then we'll and the address lines and things like that, what we can actually look at with this little toy oscilloscope. And then we'll go and have a look at Mildred's Ashtray and see whether we can figure out what's running and what isn't running. So it's incredibly simple, this thing. Let's just switch it on. We'll let it boot up, and then I'll zoom you down onto the screen, and you can actually have a proper look at it. Well, sort of a proper look at what it's doing. We need a ground connection, so what I'm going to do, I've just pulled that ground up a little bit, so it's still connected, but I can just get the crocodile clip for the scope probe on there to get a ground. What we'll do, we'll switch the computer on. I'll just quickly show to you, even though, like I said, with no 6522 in there or anything, but if we just flash up onto the screen, you'll see that the computer has actually booted up and is actually running. Right, we'll get you back down. Oops, where are you? Took you too far then. Right, let me see if I can zoom you into the screen on the scope. Wrong way. Right, that's probably about the best I can get it, unfortunately. Right, there we go. And what I'll do, I'm just going to probe, I think this is pin 3, which is one of the clock lines on the CPU. Oops. Let me just see if I can get that a little bit better on the screen. Oops, there we go. So there you can see, that's one of the clock signals. Like I said, sometimes on this it auto locks and it'll actually lock the signal. Other times, I don't, like I say, it is a bit of a toy thing, this, but it shows that the clock there is actually running. We can look at, that's one of the clock outputs. We can look at one of the other clock outputs on the 6502. We go up there and we can see there's one of the other clock outputs. And we can actually look at the clock input as well. So if we move, and there we've got, that's the clock input. So we can see that that CPU is running absolutely fine. In fact, we can have a quick look at one of the address lines. We can actually see the address line. Let's pick one of the address lines on the CPU. I think this is A10. And there we can see that the address lines are pulsing quite nicely. Let's try one of the other ones. Just to show, like I said, that's working as it should be. Like I said, the computer's booted up. It seems to be working fine. Right, so I'll switch that off now. And let's zoom you out a little bit. Oops, that's not zoomed out. That's zoomed out. Let's bring you up a little bit. Right, so basically I've shown you there what we're on this little toy, what we're basically going to expect to get off the CPU on basically a very cut down but a working core system. So what I'm going to do is I'm just going to pause the video and I'll get set up on the project computer, and I'll get the ULA swapped over, and we can have a look, see what we're getting signal wise on that computer. So back in a sec. Right, okay, we're back, and as you can see we're set up on Project Mildred's Ashtray now. So exactly the same again. I'll just connect the scope ground up. We've got it. This is all set up with the power supply that we've rebuilt, so we know that our DC voltages are reasonable coming in. So that's the scope connected up. Hopefully, unfortunately, one problem I've got is that I'm left-handed, so and I can't put the camera on the other side. So I'm hoping I can. Oops! Damn it! Just caught my computer and switched my computer on, but never mind. Hopefully you can see that, and I can get through onto the 6522 there and actually do some probing, and you can actually see what's happening there. So we'll switch on the project. So that should have power to it, and let's have a look at the CPU and see if we've actually got the clock running on the CPU. So easiest one to get to really is the third pin down on this side, which is the clock output. And let me see if I can just get it a bit better. Oops, wrong way. Oops, there we go. That don't look bad at all. Let me zoom you in. Actually, I'll zoom you into the scope. Oops, down we go. You can see what we're getting on there. Hopefully you can see it. I'm not going to obscure everything, but like I said, we're going to go on the pin 3, which is one of the clock outputs on the CPU. And if you can see there, with the clock's running, we've got an output from the clock there. Let's try the other output from the clock, which is just over here, and that's again quite nice. And we'll just have a quick look at the clock input. And that doesn't look, seems to have a lot of interference on that. That doesn't look, no, that could just be me. So that was just me causing a bit of interference with, I wasn't getting good contact on the pin of the 6502. Just press down a little bit harder then, and as you can see, we've got a clock input there. Well, obviously we knew we'd have a clock input because we've got the two clock outputs. So let's have a look at one of the address lines. So again, I think it was A10 that I looked at last time. I think that's the one I'm probing now. And that didn't look good, did it? Try another address line. Nothing there. In fact, as you can see, it shoots up. They're all pulled high. So something looks to be pulling all the address lines. Just disconnect the let's just disconnect the scope, and let's zoom you out a bit. Oops, let's get you back up on the thing. So it looks like there's something. Let's get the computer switched off as well, because there's no point having it running in that state. So it looks like we've got something which is stopping the it's stopping the address bus from communicating. Now, I must admit, I watched Gadget UK's video on his BBC micro repair the other night, and I think that was the issue that he was having, because he was having a similar state to what I'm in now, that his CPU clock was running, but his address, the entire address bus on the computer seemed just to be dead. And I believe, if I remember correctly, on his fault, it turned out to be IC72 down there. It's a 74LS 245. Can't quite remember off the top of my head what that IC is. I think it's some kind of buffer or something like that. I'm wondering whether I may have a similar problem actually. There's a 244 there, which is IC74, and sorry, IC71, and then we've got a 245 there, which now I'm wondering. I could be just clutching at straws, but I know that that's what it turned out to be an issue in the one that Gadget UK was working on. Looking here, we've got the have we got the same setup here? Now you'd expect it. I believe the one down here that Gadget UK pulled out, he got the computer to boot just by removing the IC, because all it basically does is it's like, I believe it's a buffer between like one of the serial outputs or the user port or something down here. So to actually get the computer to work, it's not essential. He pulled it out and, like I say, he got the computer to boot. I'm just looking at, we've got up here, we've got a 74LS245 again, we've got a 74LS, can't quite read that, 327 I think. Is that doing a similar job for perhaps, like, I don't know, the ULA, the video, sorry, not the video RAM, the RAM, something like that? I'm not sure. Is it going to be one of these on the data bus, which is basically failed and is just pulling the data bus high and stopping everything from working? Because that's when I probed it there, it seemed to just go high. Unfortunately, I can't get to my logic probe at the moment, so I can't. I might have to just make one. There's only about 4 components in a logic probe, just to confirm that. But it looks like all the address lines are just being pulled high on there. We've certainly not got the chatter and the traffic on them like we have on the working beam that you saw on the scope there. So that's my next thing. Like Gadget said in his video as well, unfortunately it's one of them things, because the data bus is just stuck like that. It could be any one of a number of ICs which are doing buffering or doing something on the data line, that if they fail, they're going to cause this kind of issue. And I mean, I suppose what we could do is we could switch it on, leave it on for a few minutes, and just see if any of these get hotter than anything else. I mean, it's only a really basic check, but I suppose we can. We've nothing to lose. We're not going to make anything worse by actually doing that. So I'm just going to pause the video. I'm just going to leave the board to warm up for a couple of minutes, and then I'm just going to do a little trick, and we'll see if we've got anything that's getting particularly hot, that's getting hotter than anything unusual. I mean, one thing is, because we've got multiples of a chip, and this isn't a perfect test because it depends on how much load's being put on the chip, but if we try one and it's just lukewarm, and we try another and we burn our finger on it, we've got a pretty good idea there might be something going a bit awry with that IC. So like I said, I'll just pause you for a minute or two. We'll just give it a couple of minutes just to warm up, and then we'll do a little bit of thermal testing. So back in a sec. Okay, the board's been running for about 4 or 5 minutes now. I've not left it a massive amount of time. I'll just feel the 6502. To be fair, it's barely warm to the touch. Even the video ULA, which is meant to run notoriously hot, I can quite comfortably leave my finger on it like that. It's not burning hot or anything. Same with the ROM, the virtually stone cold. By far the hottest thing running on the board is the video ULA, and like I said, even that I can keep my finger quite comfortably on the top of it like that, and I'm not feeling any discomfort at all. What we're going to do, I have just had a quick feel with the back of my finger around the board, and I can't feel anything getting excessively hot. So what we're going to do an old little trick. Take a cotton bud, an ordinary cotton bud. I've got some isopropyl here. Anything, any pure alcohol would work for this. Meths, anything. Isoprop's just nice and inert, really. Obviously, it's designed for use on electronics. So I've got just moisten the end of that cotton bud with isopropyl, and all I'm going to do is just run a little bit along ICs I want to check. And what I'm looking for is how quickly the alcohol I've applied on there evaporates. See, where he's wiped it across them two there, it's gone. Like, it takes 5-6 seconds for it to go away. If I put it on the video ULA, which is the warmest IC, perhaps 2 seconds and it's gone away. Try what? Now that it did actually let's try that one again. That's getting a bit warmer than. Now that's starting to warm up, that one. Let's just try, because we said that's a 74 LS 245. Now this is a 74 LS 245 down here. And if I stripe that, it takes, and it's cleaned off. If I do the same on this one, just wipe across there, whack, it evaporates off straight away. Now it could be that that's just doing more work and that's why that one's heating up compared with that one, but that's a possibility we may have to take a brief look at. And fortunately it's in a socket, which does make life that little bit easier. Obviously I'll just get a little bit more isopropyl on my cotton bud. It was getting a little bit dry. So we do have one possibility there that it may be. We'll carry on around some of these. Well, none of them seem to be, they all seem to be really cool. Same there. Could try the RAM chips, but I wouldn't expect a RAM chip to kill all the address lines, really. No, none of them are getting, seem to be having it evaporate off excessively quickly. No. So this is not a it's not a definitive test or anything. It can just sometimes help you spot a particular problem I see. I don't even know if one round, I think this is the video section, would actually kill the address bus, but I'm just... no. So far, that's the only one that's looking like it's getting particularly warmer than anything else. No, none of these look like they're getting particularly warm. Have a look round down here. I doubt it's anything down here. This is, I think this is audio section and like keyboard interface, more like. Look at that one again. No. No, none of these seem to be like they're getting burning hot, and that needs. I'm getting a bit dry on my thing there. No, the only one that seems to be getting anywhere remotely warm is, and even that's, it's not hot, but it's hotter than everything else. So let's just for curiosity's sake, like I say, I doubt it will boot without it, but let's just whip that out and we'll connect the scope up and see whether that gives us any of the address lines back. I'm not sure. Like I say, I doubt. What have I done with my IC puller? Just bear with me a second, folks. I've put my IC puller down somewhere and I haven't got a bloody clue where I've just put it. And you don't move out of your seat. All I've done is swivel around and reset the camera. And I had it to take the video ULA out of my BBC. So where the sodding hell's it gone? Just bear with me. I'm just going to pause the video a sec while I see if I can find out what the hell I've done with my IC extractor. Okay, sorry about that, folks, but I found them. Right, so let's pull out that IC. Like I said, I'm not holding up that much hopes for this working, but let's pull that out. And we'll switch back on. And let's have a quick probe about again, and we'll see if that's made any difference at all. Let's get the old scope out and connect it back up. I'll get you down on the scope screen and we'll see whether we've got any difference. Let's just get the scope to actually do. We'll just check that let's get something we can all see. There we go, that should be good enough. So yeah, that's working. Let's just have a look at the address lines and see if we've got anything on the address lines now. No, nothing on there. Nothing on there. No, I weren't holding out that much hope just by pulling that out actually, but like I say, it was worth a shot in the dark. But there's still absolutely nothing nothing on any of the address lines there. So we can put that. We might as well stick that back in circuit. So we'll just do a quick final check, just make sure the computer is still at least doing something. Yeah, there's our clock, but as you can see we've got, oops, let me get a good connection there. We've got nothing there on the address line where we should have we should see something talking on there like we saw on the working beeb. We can check everywhere and it's exactly the same. Like I said, there's just nothing working on any of the address lines. Oops. So unfortunately I think it is going to be a case of digging the circuit diagram out and basically trying to find everything that's something like that that's on the address line, pulling it out and having a look, see what state's changed on the scope, see if we can get any activity on the address line. We've tried the old alcohol trick, and no, it's not sure. We've not got anything that's burning hot. That's the problem. There's a possibility it isn't even the IC. It could be like a capacitor or something that's causing the issue. I suppose I should really check all the electrolytics in here as well. They don't usually, as far from what I've seen in the past, cause many issues in beebs, but because of how this has been stored and everything, I suppose they are worth having a quick check over and seeing whether they're at least fit for servicing. I mean, certainly one shorted out would certainly cause an issue, because it would pull part of the 5 volts line down on part of the board, and being that the board is fed in this strange way where we've not got like a 5 volts rail that travels all the way over the board. Instead, we've got different parts of the board powered separately off the power supply. It's quite an interesting way of doing it, really. Anyway, I'm going to leave this video here for now. Like I say, it was just a quickie little update, seeing I got my tripod sorted out, and like I say, it was easier to actually film something. In the next video, I suppose we better have a look at whipping out some of these and seeing if we can make some progress. Anyway, I'm going to leave it there for now. I hope you enjoyed this little update on Project Mildred's Ashtray. So thanks for watching, and goodbye.